Hello, my name is Andrey Monkin. I'm originally from St. Petersburg and recently relocated to Tallinn to join Evolution Gaming Company. Today I'm going to show you a brief overview of some parts of WebGL. A bit about WebGL. This technology is almost 7 years with us. It passed many iterations before it became stable and available across multiple platforms. It's based on OpenJS. That means the WebGL is available across mobile devices like phones or tablets. You can see a screenshot from caniuse.com. There is nothing to complain about except Opera Mini and all Android browsers. So the first question is why we should use WebGL if we have pretty good and easy interfaces like Canvas and SVG. Canvas provides us speedy two-dimensional graphic API that allow us to draw text, different shapes, curves, gradients, and so on. SVG provides almost the same feature set, plus we have DOM API. With this API we can mix our SVG with HTML. For example, we can render our React components directly to SVG. While WebGL provides much less possibilities, we can only draw triangles, dots, and lines. The question why we should use WebGL now is much more reasonable. It's suitable only for drawing triangles. The reason to use WebGL is we can draw a lot of triangles, thousands of them. Also, we have control of every rendered pixel, which hardly possible with Canvas or SVG. To prove that you can do something exciting with WebGL, I will show you a site linked to it. I found on freejs.com site. There are a lot of links to examples like that. FreeJS is one of the most popular frameworks to work with WebGL. First of all, let's talk about basics. You should understand how WebGL draws triangles. Triangle consists of 3 vertices with attributes. It's just float values, maybe position, texture coordinates, maybe sublighting or color properties, and fragment. Roughly we can say that fragment is the pixel. So we have 3 vertices and a lot of fragments for each triangle. Here is the usual data flow that used with WebGL. We should provide attributes and constants that also called uniforms to our vertex shader. It's a special program written on GLSL language. It's C-like language. Vertex shader should compute each vertex attributes called varings and pass them to fragment shader. Fragment shader takes them and computes the final color of the pixel. Varings. As I said before, we have only 3 vertices and a lot of fragments. So how varings passed to our fragment shader? For example, if we compute some varying parameter, color, in this case, to our fragment shader will be passed mixed value that depends on position of the pixel. Here you can see vertex shader that can be used to draw the triangle. We just get attributes from our JS layer and color. And we write color to output. Also, we set position on the screen. It's the main purpose of vertex shader. Here is fragment shader. We just get our color from varying parameter and write it to output. That's all. But do we need varings? I believe that nobody needs triangles like this in your, you don't want it in your product. But varings usually used not to interpolate colors. You can interpolate any numbers like texture coordinates, that makes sense, of course, normals, whatever we want, it's just numbers. Let's take a look on examples that explain why we need varings. Here we have a sphere that's drawn with triangles. Each rectangle is just 2 triangles. And we have normal computed for each face of this sphere. It's a pretty good example if you want to start drawing disco ball or something like that. But if you want to draw smooth sphere that looks like natural ball, you should use varings. The difference between the first and the second sphere are just normal computing. We have almost the same vertex shader, almost the same, and the same fragment shader. The only difference that here we compute normal for each point of the sphere, or not for each point, for each vertex, and interpolate it over the surface. But we have a great language, JSL, that support loops, branching, functions. We just passed a few parameters. It's not a good use for technology. Let's make some effort and make something more interesting. Here you can see bumps on the sphere. This techniques named bump mapping. The nature of this technique is that we compute normal not for the actual surface that we have, but for slightly different surface. With this technique, you can make something nice looking shaders. I can show one that's made by La Bodelson. It's another great resource, shader toy. I think it looks good, really good.
Amazing.
Of course. So what we have in these three spheres, the difference only fragment shader. We have almost the same vertex shader. We didn't use colors. They have the same amount of triangles. We didn't use textures that buffer or other possibilities that WebGL provides. And we achieved different level of stylization. We can do a lot only with these instruments. So there is a huge room for your creativity, slightly limited by device performance. Devices now are pretty good. Yet another example. You can find a lot of nice examples at shader.com. I recommend you to visit this resource to see what can be done with WebGL. It's not a resource that explains what can be done with WebGL. It's mostly about shaders. And even with 2 shaders, you can achieve that great result. So, thank you. You can contact me or ask any questions if you want.
Thank you, Andrey. Yeah. Oh, we have already a question.
Hi, my name is Evgeny. Thanks for the talk. So my question is, can you provide some practical examples where you have used or where you could use this WebGL technology?
I didn't use WebGL in my work. I had my own project before my work. I made vector graphic editor during a year before joining Evolution Gaming. That's the place from which my experience comes.
So, is there a big difference between WebGL and, for example, OpenGL, and how could I use my experience in WebGL in OpenGL and vice versa?
If you're already familiar with OpenGL, you can easily switch to WebGL. But WebGL based on subset of OpenGL because it should work on mobile devices. So you have no, for example, geometry shaders and a lot of other features of modern WebGL or OpenGL.
How is it possible to track events in, like, how do you use it on mobile, for instance? Can touch events be registered?
Canvas, WebGL works over the canvas. So processing of events looks similar to usual canvas, but they're two-dimensional. So you have a point of touch, and you should understand which object is located here. Almost. It's upon you.
Yeah, I have a question also, probably. How do you do debugging with the WebGL? How painful it is?
It's quite painful. There is some tools, I didn't use them yet. If you have compilation error, it can be easily fixed because you have a message about place of the error. But if the problem in your computations, you can put breakpoint at some point. It's impossible because shader scope executes on GPU. There are a lot of threads, and communication with CPU and GPU is quite slow.
How about performance? Is there, for example, some problems on the mobile device performance-wise when there are some complex models?
It almost always depends on your code. The performance in average case is the same as with Canvas, as usual Canvas. But with WebGL you can put your geometry once to a video card memory and then process with different shaders or pass different parameters to shaders. It should be much faster than drawing with Canvas, because with Canvas you should provide geometry each time for each frame. There is much more data flow, much more intensive. So you can achieve much better performance.
I'd like to ask, are there some patterns in this kind of programming? For instance, in object-oriented and function programming, there are some common solutions, common patterns. What kind of similarities, or what kind of some common solutions, common tasks are there in programming shaders?
As I mentioned before, there is a special lot of libraries. One of them is 3JS that I recommend you, but it's all about JavaScript layer. If you want to do something inside shader, you are quite limited with it. There is a lot of hardware limitations. For example, you can't use recursion in functions. You can access to array elements with variable. So it's not so easy to write something object-oriented or functional with shaders. You can think that it's assembler with improved syntaxes.
Yeah, sure.
So why is it better than other tools? Maybe some major points.
It's not better, it's other. For example, if you use SVG, you have DOM API. You can easily handle clicks on your objects. If you use Canvas 2D, you can draw curves, text easily. You can draw text with WebGL, it's not so easy. But WebGL provides performance and control over the pixels.
So maybe it's possible to use WebGL instead of JavaScript, not to use JavaScript directly and to use WebGL and to write some dynamic code. Is it possible?
No. You should provide some data to shader.
Mm-hmm.
There is nothing to work with browser with WebGL API.
Can you do WebGL with WebAssembly?
I think yes, of course, because WebGL is just API, and WebAssembly is just compiled to JavaScript.
Is it a stable standard or is it still in development?
As I saw, it's supported almost everywhere, so it's quite stable.
I mean, if it will be changed from version to version, and maybe it's difficult to support previous versions.
We already have a second version of this standard. We can, for example, in Google Chrome, we can turn it on just by one mark in settings. But when you're asking a context to draw, you should specify a version.
Mhm.
So if you write a program that used WebGL first version, it will work all the time. And if you ask the second, you will work with second.
So browser supports some old versions of WebGL at the same time.
Yes, and the first version of WebGL is subset of second.
Okay.
Okay.
Thank you, Andrey.
Andrey.
So it has been a nice introduction to WebGL, a fast track to WebGL, and I really look forward that Andrey will come soon with some advanced topic of the WebGL, showing some game and animation. But thanks a lot. As we have promised, we will choose or propose a best question, and we will give this opportunity to the speaker to choose the best question. Andrey, do you have any? Which question you like? To nominate this.
I think a question about possibility to use object-oriented or functional functions is quite good.
Yeah, maybe I
I
also
also
might
choose, but
But I recall this one, yeah. So the one who asked, you didn't present you, but yeah, I remember. So Iva, we have a gift
Yeah.
for